OWL started actually being developed here at UMass in 1996. They had been using an online homework system for quite a few years and found that it just wasn't fulfilling the needs they needed for their classes, and looked around for something that could be used to replace it, didn't find anything, and between them and the computer science department decided to make something on their own.
We knew we needed something cross-platform that was easy to use, that would run from a central server, so trying to put it on the web seemed like a logical place to start. We built it over a period of about 6 to 9 months with the chemists and started testing it in their classes, and it worked.
We used it with students for the first time in the spring of '97.
What it enables people to do, or an instructor to do, is assign homework and not have to grade it themselves. And it enables the students to get immediate feedback, where students used to do paper homework and then hand it in to a professor, and maybe they would get it back graded, but it might be a week or 2 weeks later. This allows them to work on their homework and get instant feedback, which really helps the students be successful.
They do most of their learning outside the classroom. We might like to think that they learn by coming to our lecture, certainly my lecture, but the students really do most of the learning when they're working with the material.
It's really a lot easier to learn, at your own pace, to really help you prepare for exams and help you just in general really practice and learn.
It allows you the opportunity to spend more time talking about the concept, talking about what that concept means in the context of their lives.
It's a safety net that I know all of my students have. And so there's tutorial help that really is hand-holding help for students. It often helps them, gets them to where they need to be, but if not, then they can come see me. It's the first line of defense for my students to get the help they need.
It allows for you to really get a good grasp of what you're learning and get feedback on what you're doing wrong without having to have an instructor right there for you, and it gives me kind of feeling like I did it all by myself.
Mastery learning at its most basic is that the students can work and work and work until they get it right.
Think of it as a loop. Students enter the loop, and those students who comprehend the material are able to exit the loop more quickly.
If they don't know it, that's where it actually gets to be interesting and really useful. In that what then the system does is it gives the student feedback and help, and then gives them a new problem to do again. And the idea is that the student can try that over and over again until they actually get it.
The most unique part of OWL is the fact that questions are not static.
Every time going through the loop, those questions randomize. So OWL having 3 levels of randomization, the numerical, the chemical, and the contextual, truly sets it apart from anything else.
The parameterization is really the linchpin of being able to do mastery learning. Without having really richly parameterized problems, mastery learning doesn't work because you can't allow students to do problems over and over again and have the problems be different enough.
Maybe the structure of the compound has changed, or maybe the chemical reagent that's used has changed. The student can again attempt to answer the question, and if enough has been learned that first time, then maybe the second answer is right.
The idea, though, is that the students eventually need to get the problems correct. They don't lose credit for getting something wrong, but they end up getting credit when they get it correct.
General chemistry tends to, a lot of the time, deal with numbers, and organic chemistry deals with pictures. And so we needed a program with which a student could draw in a chemical structure showing how the atoms in a molecule are connected to one another, and the OWL program then could judge the correctness of that as a chemical structure, not as a picture, but as a chemical structure. And so that is supplied by Marvin Sketch. There are also simulations in OWL where a student can simulate situations and then stand back and observe what happens. So in a sense, it's almost like being in a laboratory and experimenting. We use an open source program called JMOL to visualize molecules in 3 dimensions. The student can cause the molecule to tumble around, and when they do that, the 3-dimensionality of the structure jumps out, and that 3-dimensionality is an absolutely critical part of chemistry.
I love working on the OWL team because we actually are always on the author side, always at the forefront of being able to do new innovative ways of using web-based media to teach students and to help students.
This is an ongoing effort to continue to evolve the technology in ways that makes it more effective.
And that's why we engage with people from the educational community, because we want to make sure that we are on the cutting edge for building the best learning management system that we can for really the purpose of enhancing the educational experience.